Okay. Good afternoon, everyone. So far, we looked at different methods of testing, right? So last week we looked at white box testing. Before that, we looked at black box testing. And today we have we go beyond that. So we in fact look at levels of testing. So those are the techniques of testing that we've seen so far. So today, what we will be looking at is the levels of testing, because when it comes to testing, you can control like how much level you go into. So do you break it into, small pieces and you test it, or you test the whole thing at once? Or do you look at component-based testing? There are different ways of testing, right? And each one is having their advantages and disadvantages. So we are going to look at some of the things today. This is a vast topic, actually. Because levels of testing controls how deep your testing is, or how comprehensive your testing is, right? And if you remember our earlier weeks, we talk about how much to test, right? So are you going to test everything? Are you going to test certain things? So it depends on how much you're testing. So levels of testing is directly addressing that question, right? How much of testing we are going to do. So if you look at the definition of levels of testing, so we are looking at the stages of software, okay? Essentially, our aim is to verify the quality and functionality of the software, right? So not only the component, we are also looking at the functionality. So of course, here also you will notice there are certain things that are white box testing, and there are certain things black box testing. So this is where we bring in all kinds of testing together, and we are looking at the software, the completed software, and see, right, okay, how are we going to now, what is our strategy to test this under the program, right? So starting off with the levels, now there are 4 main levels when it comes to levels of testing. Some we discussed. I think yes, last week we looked at unit testing with our Java program. So I showed you how to use NetBeans, and very simply you can create a test case for your class or your functions, and it will generate the code for you. You just need to go and change the code a little bit, and then you have a test suite, right? Now, where do you put it now? Does it come under unit testing? Does it come under integration testing? Things like that. So we need to go into the detail and see. That is just one example. So that's actually white box testing, where we look at the source code, we also look at the test code, and then we try to understand what is going in there. So unit testing is where you take individual component, right, or a module of the large software. So it might be a class, it might be a package, or it might be even a function, right, within a class. So we call them the unit testing. So you're taking one unit, one component, and you test that. And then comes the integration testing. So your class or your package may be working with other packages, so other classes, so other components, right? So do they work as we planned earlier? So that is integration testing, right? This is about between different components. Are they communicating properly? Are they breaking something or the other? Because when it comes to software development, there may be one team developing one component, maybe another team developing another component, or even 2 different people are doing 2 different components. So how do you know that both of them go through the same specification and they work together, right? So that's what we do with integration testing. And the third one is where we bring all the components together, right? You might have hundreds of components. You put everything together and you run the entire system, right? So unit testing is the smallest piece of testing. Integration is where you put multiple components and test it, maybe 2 components at a time, 3 components at a time, and then 5 components at a time. So you are bringing various components and test it. Not the whole thing. So when you test the whole thing, the entire software, we call that system testing. right? Now, if you have done your unit testing and integration testing earlier, your systems set testing should be smooth because you already tested the interchanging of that. But more on the functionalities under system testing, what we are looking for is performance, security, and also compatibility with other systems and usability. Now, for example, when I run the software, how much memory it is taking, right? Say I have 8 GB RAM, and when I run this software, it takes 7 GB RAM. Then we have a serious problem, right? Or what about security? Now, when this program is running, is it easy for anyone to hack into the system? So if that is the case, then we have a problem, right? What about the performance? Like, for example, what if 100 people accessing the software at the same time? What about 1,000 people accessing at the same time? Or what about 10,000 people accessing at the same time? So performance is about numbers, right? Where does it break? Does it break at 1,000 users, 10,000 users, 1 million users? So we can only test it under the system software testing, or rather system testing method, right? Because you're testing the whole software. Now, the first three are generally done by the software company or the development company, by the developers. The last one, called the acceptance testing, is done by the users, right? Now, once you're done unit testing, integration testing, system testing, we hand over it to the customer and say, look, okay, here's the software. And of course, they won't be using it for their production use. They will be going through, there are other levels. There is something called alpha level, beta level, production level, things like that. So, but all those testing are done by the users, the real users of the software, right? So that is known as the acceptance testing, or in short, we call it UAT, user acceptance testing. So they don't know anything about the internals of the software. So what they are looking at is, does it meet the expectation, or does it meet the requirements that they gave originally to you, to the software development company, right? So that is their job. Okay, we gave you a specification, you gave us the software, now are they matching? That's what they test it. So these are the 4 main levels of software. Now, this nice picture is showing in a very graphical way our store here, right? So you can see, okay, there are 2 axes. On the leftmost, you can see the vertical axis, where you can see earlier at the bottom, later at the top. That means when you start the project, earlier, the starting of the project, you can do unit testing, right? Later is what happens, what is on the top, right? So in this chart, acceptance testing comes at the end, later to the project. Also on the horizontal line, you can see on the left, we have simple, and on the right, we have complex. So that means unit testing is simple, and you can do this earlier when you start the project, right? So as it says, testing individual components, and you bring these individual components together to do integration test, right? You are putting things together and see whether they are working okay. And then you bring individual component together to try the entire system test, right? So it's like, building a bicycle. On the unit test is where you are in one section, they're building the wheel, right? In the other section, they may be building the tires. Another section may be building the metal frame. Another one may be building the seat, right? In the integration test, you put things together. You put the tires, you put the seat, you put the handle, pedals, all that you put together and see whether they are all fitting it properly. Now, sometimes the structure of the bicycle with the seat will be done by one person. So that can be an integration test. Maybe another person is fixing the wheel to the structure and then testing that and see whether it is okay. Another person may be fixing the gearbox and then testing that separate. And the system test, you have the complete bicycle, right? So internally, a technician will be riding the bicycle to make sure that it's, no problem. It is passing the test. So that is a system test. Acceptance test is where you actually sell the bicycle to a user, and the user start riding the bicycle. and then giving you the feedback saying, look, the height is too much, or the tire is not smooth, or it's very fast, or whatever, positive, negative, any feedback from the user comes under the acceptance testing. So once they ride the bicycle, the user, and then they will say, right, I like this and I will buy this. Okay. So in this case, the user, if they don't like this bike, they can buy another bike. But in software development, you can't do that, right? If they don't like the software, now what do? You can't say, wait, we'll give you another software. Well, you need to then come back and see what happens, where we went wrong. So that'll be very expensive if you're getting that at the time of acceptance testing. So that is why you have multiple levels of testing to make sure whatever we are doing is correct according to the requirement of the user. Okay. So this is one way to look at our testing. Here's another way to look at our testing. If you look at the leftmost, you have the dev team, right? The development team is doing the unit testing. So generally, it's a very technical thing done by the developers and also code reviewers. Maybe they are team leaders. All technical code writers will be doing the unit testing. And then comes to the integration testing and system testing, generally done by the QA team, right? So unit testing is a white box testing method because the source code is available for everyone, whereas integration and system testing is a black box testing where the source code is not available and the QA team is going through those methods. And then comes the end user who will do the UAT, or the user acceptance testing, right? And only when the users sign off and say, right, I'm okay with the software or everything is fine, then only the software goes to the client. If the user acceptance testing fails, then we don't have a customer. Customer will not pay us, right? So the whole company's goal is to get the users to sign off and say, yes, we know what we want and this is what we want, right? And when they sign off only, we get paid, all right? So testing level is very, very important. I hope you can understand from this simplification where we are heading with the testing levels. Now, let's go down to some details. Okay, so that's the higher level of testing levels. Now, in fact, under the top layer, we have 4 here. We have unit or module testing. We have integration testing. We have system testing. And then we also have something called the regression testing, right? And if you take the integration testing again, that can be broken down to 4. There is something called top-down, bottom-up, big bang, and threaded integration. So we'll take each one and see how it works and what it is. And then if you take the system testing, there is coming under that is acceptance testing. Now, acceptance testing, again, can be broken down into sometimes 3, like alpha testing, beta testing, and production testing. In this diagram, we see alpha and beta, right? So regression can be your final release testing also. So these are the levels of testing and software organization we'll be going through when it comes to development. Right. So let's start with the unit testing. There are so many things you can see. We'll start with the unit testing now. And it is a white box testing technique because the source code is required and is available, right? So what is unit testing? Process of taking a module, we call it the atomic unit. Atomic unit is like the smallest unit of the software, right? So we take the atomic unit and then we isolate that from the rest of the software or the product, right? So it's taken away and it's not there now. Atomic level meaning you break it down into simplest, smallest piece and you test it, okay? And you, of course, have a test case, test documentation and things like that. And you are testing, you're basically comparing that in your testing, right? So you prepare the test cases, compare the actual result, right? And then You can also predict actually. Before you test it, you know what kind of result you will be getting in. And then you also have a spec, and then you compare it as per the specification. Right. Now, what is the importance of unit testing? I think last week I showed you a sample of writing a small piece of unit testing using NetBeans. So there, the reason is the modules are being tested individually, right? And when you are looking from the complexity point of view, when you are testing each module, your testing becomes easier, right? And also because you go to the smallest function, isn't it? And then you test it. So it's easy rather than testing something very big. And also it is more exhaustive. What does that mean? Exhaustive means it's complete. You're testing everything, right? And interface errors are eliminated. Now, what does that mean? The interfacing meaning connecting one piece into another piece. And those problems are not there when you're doing your unit testing, right? And what is the purpose of this? Why are we doing the unit testing? One is to verify the accuracy of a section of code. So now someone has written the code, and then another person is going through the code to understand how this piece is working. And then number two is to have a separate independent section of a code, right? So since you're testing a piece at a time, it also becomes easier when you're testing it. And since you have access to the source code, it is also very easy to locate and find the bug as well. Yeah. And then if you look at the code now, actually this is coming from the code reviewer's point of view. So if you are a code reviewer, you will understand how the programmer or the developer was thinking about the problem, right? And then if you give the right sort of feedback, the programmer or the developer can improve his skills, right? So this is a very good way of developing our developers. So if there are junior developers, when they go through unit testing, feedback is very important for them to learn the best practices and figure out bugs in the early days, earlier than later. And also, whenever you make a small change in a unit, it has a big impact on the connected modules, right? So your changes are very effective. They have a direct impact to the entire code. And once you fix the code, right, the code becomes reusable because it's already tested, reviewed, and passed from a certain test. That code is better than a brand new code, isn't it? So a code that has come out of unit testing is much better than a code that did not go through the unit testing. Now, unit testing is good, but there are also certain challenges with the unit testing. Number one, if you notice last time, we had to come up with names for test cases, right? Generally, we take the function name and then add the word test in front of that. Okay. And when you have like a loads of programs or classes and methods, it will be overwhelming, right? And also now, if you want to test one function using multiple mechanism, multiple ways, then we have to come up with our own naming convention. You got to be careful there, right? And also wrong test type. That is also possible because you're supposed to be testing a certain way and you end up writing the code in some other way. right? Now, the third point is important because the unit testing, although it's a unit testing, you're only testing the unit, right? So you wouldn't understand the entire code. Now, sometimes you may need to know the whole code also, right? That will be helpful. So, but with unit testing, you can't do that, right? Because you are exposed to only a certain unit. Now, unit does not mean one function, by the way. Okay. Unit might mean a class. Unit might even mean a package, right? So, which is part of a bigger picture, a bigger program, a bigger solution. And then what do you mean by need to test doubles? Now you have code in your real code, and then you need to write the same code in order to test it. Actually, not the same code, but similar code to test that, right? So in fact, there is a concept called TDD, test-driven development, which is coming as part of the unit testing. So in that, you first write the test code, and then you run the test. The test will fail because you don't have the code attached to the test. And then you start writing the code and test again. You write, in fact, the minimum so that your test will pass. Okay? And then you need to go back there and do something called refactoring. You have to refactor that code to write it properly. And then start adding the comments and various things into that code to complete it. So if you do that process, the TDD process, some people say this is better, that you're not wasting time. You're also properly testing and also developing the test cases. Okay. And the next is lack of proper initial conditions. What does that mean? Initial condition is where when you start the program, there are certain default variables. If it is like a login system, a default person login or not login. Are you showing the, let's say, a login screen? So, things like that. And then if you're testing one piece, say one function, you don't know under which initial condition your program should be running. Yeah. Let's say you are testing the salary calculation of the logged in user, but the user is not logged in, right? So how are you writing your test code? So you are writing to check the algorithm of the, let's say, salary calculation, but you can't run your test because the person either not logged in or the person is not there or the person doesn't have a salary account. So you then, in order to test the salary calculation, you need to also set up the initial conditions before you go to the testing part there. Okay, which means you need to go backward to find the dependencies. So you are trying to test the salary calculation. You can't do that because there are certain things before you have to check. Right? So that's what it means by finding dependencies. So here's a life cycle of unit testing. Right? We can start from the top. Check out code from the repository. So what does that mean? So you have a GitHub or a Bitbucket or whatever where you are checking the code. You're downloading the code. That's called checkout. And then you make some changes. And if you have not written the unit test, and if the code is an old code, somebody somewhere may have written the unit test. And when you are running the unit test, it will either break or pass. And then you need to fix the defects and then re-execute the test. You find the problem, you rewrite the code, you test again. And then since you change the code, it has to go to the code reviewer. Somebody has to review the code again, right? Once the reviewer thinks this code is fine, he or she will absorb that to the main branch of the repository. So this is the usual life cycle of unit testing. Okay, take the code, make some changes, run the unit test, fix if there are any issues, send it to code review. Now, if you don't have problems, you still need to send it to code review. Maybe you didn't test it properly, right? Or some unit tests were not complete. In either way, you send it for code review, and the code reviewer is the one who will absorb or approve the code to the main repo. Now, talking of unit testing, now we use JUnit last week, right? That is I think the default one that we got from the Java. So last week we were using JUnit, right? Which was part of the Java system. It was pretty easy also. All I had to do was right-click, create test file, and then boom, I got the files. And then all I need to do was to go and comment some things and then add some testing data and whatever. And if you're using C#, Microsoft, then there are other solutions there, like NUnit, Haskell is available there. And if you're using PHP, there is again PHP unit is one very famous one available. Then there is also Behat, Mink, and there are also very good recent ones available also for PHP. And then if you are using the language called Ruby, there is RSpec and test unit available. And then for Python, there are again unit tests, PyUnit, PyTest, robot framework. So various frameworks are available as well. Okay, so these are some of the frameworks available for testing. Right now, the objective of the framework is to help us build unit testing. So for each unit, for each function or a class or a package, we can use this depending on the language. We use the framework. You may have to install that, and then you have to go through. Actually it's another system, so you have to learn that system also. Sometimes it is integrated with the IDE you are using, so it's part of the IDE and then the software. So you have to learn everything, like how do you use your IDE to do the unit testing. Right. So before we go to the integration testing, let me quickly show you what we did last time. Okay, so here we are. So this is the this is the program I wrote. Yeah. So this is the main class. The name of the class is tester. And inside that, I have a method called do nothing. I have a method called sum. I have a method called main. Okay. So when I do a normal running of the program, I just go and press this. And I'll see the output here. Right. On the right hand side, you can see the output. So this is, it says Java test, total is 5, right? Java total is 5. So the main program is calling the sum method, which is here, with 2 and 3. And then it adds the 2 and 3, answer is 5, and it is returning back to main, which is available here. Okay. And the do nothing is doing nothing, actually. It's not running at all, right? Now, this is the normal running of the program. And if I want to test it, I need to go here. This is the test code that was generated. Now you see, I have my main code, I have my testing code. So that also, if you notice, I have a constructor method called tester test. Unfortunately, I'm using the word tester here. So it is saying tester, which is my class name. And then after that, the test. And then test sum, test main, test do nothing. So the word test is added to the name of the function. So it is testing the sum function, giving 2 and 4, expecting the result 6. And if the result is okay, right? So there is something called assert equal. So I'm testing the equality. So the sum of the sum method of the tester class should return something which I'm storing in the result variable, and I'm comparing that with the expected result variable. So expected result, is it equal to result? That's what I'm testing with the assert equal. Okay. And if you notice, in the beginning, this was online, fail, right? I mean, it was, I commented that because fail mean to fail. I can fail by force, I can fail also. So it was there. And also this line at test is also important, which means the following method is a test method. Okay. So this is testing the main function and also testing the do nothing function. So if you go to debug and if I say debug test file, right? So here you can see it is testing. It's running down here. Okay, test 3 finished successfully. Okay, open test result window, all green, right? All test pass, right? So here are the test results, sum, main, Java test 5, do nothing. So this function will never be called. Okay, that is also returning. So this is, by the way, my test result. So what we did last week was we basically wrote test functions to function our main function. How did we do that? We go to the main function, did a right click, went to tools and selected create update test. This is where we checked what we wanted. Method access level, generated code, generated comments. You can turn on, turn off anything you want. Right. And also the framework. Now I'm using JUnit. There is also other things available. TestNG, JUnit 4, Selenium, right? Selenium is mostly used for web forms, but since I'm writing a very simple program, I'm using the JUnit. Right. So that was an example from last week. Yeah. So that's on unit testing. So let's move on to the next one, integration testing. So what does that mean? It is a type of testing and a pace of testing, right? It is also a type and also a pace. What does that mean? So here's the definition. The system is composed of multiple components or modules that comprise hardware and software, right? So when someone asks you, what is a system? The system has hardware and also software. So integration, what does that mean? Integration is defined as a set of interactions among components. So there are components, they are talking to each other. So that is called integration. So testing the interaction between the modules and interaction with other systems is externally is called the integration testing, right? And both a type of testing and a pace of testing. So integration testing is a type and also a phase. And the architecture and design of a system can give the details of interaction within systems. So if you look at a system's architecture and also the design of the system, will give details about how the modules are talking to each other, isn't it? So if you want to understand how the modules are talking, you have to look at the architecture of the system, right? So if you want to understand how these pieces are talking to each other, you must have a very detailed understanding of how they work together. So here's an example in a picture, right? So the previous one, unit testing, we had 3 units, module A, module B, module C, right? And when you put together and test it, what you're doing actually is integration testing, right? Under integration testing, they are all put together and they're working in a cohesive, combined unit. So these are individual units. This is the combined unit. So this is called integration testing. Now, that also can be broken down into 3 areas: decomposition-based integration, call graph-based integration, and path-based integration. Okay. So today we're going to look at the decomposition-based integration. We need to also understand, because when it comes to software quality assurance, testing is a big deal, right? Testing is a big deal. And then comes the quality assurance. Okay, so remember there were 2 things. Where the testing is looking at the final product. Quality assurance is looking at how you do things, right? Now you notice the things we are talking now have inroads to both, isn't it? So like it says, the integration testing method is, if it is incorporated to your code writing, or if your unit testing is incorporated into code writing, you are assuring the quality of your software, isn't it? Because testing is already integrated to your process, right? So if you take the first one, decomposition-based integration, there is top-down, bottom-up, sandwich, and big bang. Those are the 4 ways of doing decomposition-based integration. So we're going to look at that today. Now, what do you mean decomposition? Now, remember in our, sometimes in our house, we collect our garbage and we put it into a bin so that after a while, we can create compost fertilizer, right? You may have heard of that, creating compost, right? Compost is basically breaking down our waste into pieces, small pieces. That is called decomposition. Okay. So the bacteria and the others who's living in the food waste will break it down, break our waste. So it's called decomposition. So we do the same thing here. So decomposition involves breaking down complex systems or problems into smaller, more manageable components. So we are not talking about just the function. We are basically looking at the big problem, or big complex system, breaking it down into manageable components. So these manageable components can be classes, packages, even functions. Okay. So generally we will get a tree of things, so showing, okay, this piece is connected to the other piece, right? And this level is on the top, and then we have another level, so there are 3 levels here, things like that. So we will have a graphical view of all the components connecting and talking to each other in the system. So this is called the architecture diagram. All right. So this decomposition-based testing can be broken down, or rather classified into four things: top-down method, bottom-up method, sandwich method or the hybrid method, and then Big Bang integration strategies. Right. So Big Bang is the last one. So these methods assume one thing, one very, very important thing. That is, you already have the unit test in place, right? Or at least unit testing is done. So you can't do top-down, bottom-up sandwich without assuming that the coders have written the unit test for these things under test. Okay? So the goal of the decomposition-based integration is to test the interfaces among separately tested units. So now you have your unit test for different components, and here you're trying to see, when you put it together, are they working? So you still go down to the small pieces and see whether they are still working. So let's see whether we can write a sample code today also to understand what you're talking here. Right, so let's start with the top-down method. Okay, now the diagram, as you can see, shows that we're coming from the top. We call it the root circle here. Okay, so this is called the node, by the way. So the root node is M, and the M node is connected to 4 subnodes or other nodes, right? So there is S is a subnode, M is the main, let's say main program or the main code, right? And we use a term known as stub, S-T-U-B. Stub means it's just a empty function. There is a function, it doesn't do anything. Like the function that we wrote, do nothing. Well, the name of the function is do nothing, it actually does nothing. But in programming, we can write something called the stub functions. Proper name, proper parameters coming in, proper parameter going out, but the logic is not written within the function, right? Maybe you return some specific data so that we can test it. Okay, so when you are writing code, you don't write the entire logic of the code. You start writing the functions. Basically, you are mapping out your program. So you write the first main class maybe, and then internally you will, let's say you need 5 methods, you write the 5 methods. You just put the name, open close brackets, that's all. That is called a stub. Okay. You see, it says a stub is a piece of throwaway code that emulates a code unit. Meaning, like the source code I showed you previously, you write the absolute minimum. Maybe you can even throw it out, right? You just need to see whether the function is getting called. So my advice is, okay, you don't have to throw it. So write the proper signature of the function, and then you can maybe later develop it. So there is also a formula here, right? Number of stubs required. So if you know the number of nodes, right? As in like how many endpoints you have in the code. Okay, let's take an example. Say we have a switch case function where you're displaying a menu to the user and you're expecting 1, 2, 3, 4 for some selection from the user. If they press 1, you do something. If they press 2, you do something else. If they press 3, you do something else. And then if they press 4, maybe you want to exit, right? Something like that. So now we have 4 cases, isn't it? So 4 plus the main is 5. All right. So main is anyway working now. So 5 minus 1 is 4. So you need 4 stubs, right? So we'll write a little piece of code and see whether we can understand that after once this is over. So once you write all the stubs, okay, we can then run the main program. Of course, you might need a test code or a test unit to test that, but you can find out whether it is actually giving you the output as well. Okay, so we can apply any functional or structural technique to look for faults. So the example I gave you was a menu program, right? You display the menu and then you give a selection and then you expect to see a certain thing coming out, right? So if we think the main program logic is correct, we replace the stuff with the actual code. So maybe when you press 1, it returns 1. So we know, okay, 1 is coming back. Or when you press 2, it returns number 2, right? So then you know, okay, number 2 is coming. And if number 2 is not coming, that means there is an issue with the code. So once you know all your numbers are coming back to you, then you go in and replace the code. Okay. So we have another terminology here, breadth first traversal or BFS. Now, if you look at a tree structure, there are 2 things, breadth and width, right? Or the height or the depth, let's say. The depth is going from top to bottom, how deep you're going down. Breadth means from left to right, how wide you are going. So the top-down integration is about wide, isn't it? How wide you're going to left to right. So breadth first traversal. Right. Now, before we go to the bottom up, let me go back to the diagram and see whether we can write a little piece of code. So I'm doing a live code now. So I hope it'll come out okay. So let's see. Java application. Next, let's call it top down. Yes, no, let's call it top down. And I'm going to remove this package on the left hand side. So let's call it top down and then say finish. So, okay, now you have to open this project. All right, so I don't have a source package, so I may have to create one, right? So let's create a Java class. I'm going to call it top down. All right. And I'm just going to get this one here. Let's see whether I can run this without any problem. Oh, no main class form. It's not picking up my class. Did I go wrong? Okay. Some naming convention issue. Okay, so I have my one here. So let's call it top-down integration test, and we'll run it, and it works. Okay, it is working. Okay, so what I'm going to do now is to, let's say, create another class, right? And from, let's say, the main method, I'm going to call that class and see whether I can understand the top-down method there. So let's call it menu. Okay, so it's a Java class. Let's call it menu. And the menu will basically display a menu on the screen. So let's have a public void display. Okay, so I need to have welcome to ABC Bank. The one deposit money. To so let's make the last one as exit. Okay. Okay. I think I have a spelling mistake. Okay. So if I run, nothing happens because it's not displaying anything. And I'm not calling the display method. Okay. It is still missing few pieces. So I need to get the user input. So in order to do that, I need the scanner function. So scanner, let's call it in new scanner system between. I hope you know what I'm typing here, right? So I just need to import Java util. Also need a variable here. So let's call it choice. Okay, that will be an integer. Okay. And I need to display something else as well here. So is an choice. And the ln so that I can get the input here directly. So all I need to do is now get choice dot choice equals in dot next int, right? So we're getting an integer from the user. Okay. Now, what do you do when I get the user's input is my next part. Now, before I get to that, let's see whether I can call this. So I'm in the same package called the top, right? So package is the same, no problem. Here, I need to create an object out of my the menu class, isn't it? So let's use menu. Let's call it menu with simple m equals new menu. Then I'm going to call menu dot display. All right, that's it. Let's see whether this is working. It is working. So here it says top-down integration test, welcome ABC Bank, deposit money, transfer money, retrieve money, exit. Please enter your choice. All right, so can I enter number 5? Yep. Anything I enter, it sort of exits. Okay. Nice. Program is working. Now, where is my testing then? Well, in order to test this, I need to know whether I am going to break this program into different functions for each one here. Okay. So for that, I will create different function inside this class. Okay, so this is called the menu. So here, let's do public void, or not actually void, let's say I'm returning integer, yeah? I'm writing a stub, okay? So this is called deposit. Right, so am I getting something in here or I'm not getting anything in here? Okay, let's say I'm not getting anything here, right? And all I do is return 1 because deposit is number 1. Okay. We can also have some, let's say, comments. Let's say handle deposit actions, right? Done. So if you call deposit, it will return 1. Okay. I can also, in fact, have a system out, and then I can put the same thing here. Fine. Now, how do I call it? So here, I need to have a switch case function, right? Switch here case. If the case is 1, oh, sorry, here I need to have choice. So that's some using case 1. What do I do? Call the deposit function. There we go. Okay. Now let's run again. I'm not writing test code, by the way. I am just writing my code. So let's see 1. I'll also show you how TDD can be done. So it looks like this code is working. Yeah. So my deposit action, it says here, deposit action is working. Now let's write the test code for this. This is manual testing I'm doing, right? So I'm going to do a right click here and say tools, create update test, right? Top menu test package, JUnit, public protected package by source code in Java. Right. Okay. Here we go. Okay. So I will have that source code inside the test package. There we go. Okay. So if you notice here under the menu, I have a display method and a deposit method. We have a test display, test deposit method here. And if I run these 2 tests, you see I have a fail and a fail. Both will fail because there is a fail statement. So if I go to debug and say debug project, run my test cases and both will fail because I have the word fail. Okay, still running. test case are still running because these were the first time. Right. I guess you get the picture, right? So I'm waiting for this test to run. In any case, what I'm actually doing here is I wrote my first code, rather my main code here. And then I wrote another piece of class, which I will be testing later. And I'm approaching a top-down method, right? So this is my class, which is display. And then for each item here, I will need another function. So I wrote the first one called deposit. I can have another one for transfer, right? So it can be public int. Now, by the way, these pieces of code are called stubs, right? And the transfer also, since it's expecting an int, I can return, let's say, number 2, because number 2 is the transfer option. Okay? Right. I can, in fact, try this also. So it will show me number 2 if I run this now. Let's see whether it works. Okay, the menu is coming. Right. I'll enter 2. It will say, please enter choice number 2. Yeah. So since I'm not displaying anything, it's not displaying anything. So I could display, handle a transfer here or something like that. So let me copy that also here. So this is, I'm actually combining manual testing here transfer action, right? So when I run that and give number 2, I should see transfer actions. So in testing, what I'm actually doing here is number 2. I am basically testing the pieces of code here, right? Now, actually here, I have a test deposit, but actually I can't run the test display automatically because right now it is displaying, it's calling the display method, and then it doesn't go further because there is an input, right? So I can't actually test display automatically because display will be displaying something and then expecting a user input to come. Okay? So that's why it didn't work. And then it fails automatically because I don't have any code as such to do it there. Let me run it for one more time. Debug test file and see whether I can enter something. Okay, here we go. Let's type number 2 and see. Yes, number 2. I think it's not moving forward with my display. Anyways, right? So the point here is that I write my program. I write the pieces I want in my program. And for each piece, I will be writing a test case. Now, actually now, since I have it here, since I wrote another piece, I can go here and say, create the rest of the pieces also. Now, if you go to the test code, now I have the transfer test as well. Okay. Now, if I don't want the test display to run, I can actually turn this off. So if I turn this off, let's see now whether it will run without calling the main file, because it is waiting for me to enter something. It will directly call the other two method, test deposit and the test transfer, right? So that way, you notice it is red because I have failed line here. So let me, like we did last time, let me comment it here. And when I call the test deposit, I need to have number 1 as the expected result, isn't it? So I am expecting number 1. And now it should pass. So right now I'm expecting 0 here, expecting 1. So this should be expecting number 2. So let me run again now. Debug test file. So if test deposit method runs properly, I should get number 1 as the result. And if the test transfer method run properly, I should get number 2 as the result. So let's look at yes, it's all green, right? It's all green. And here's the output as well. Green because I am expecting number 1 here and expecting number 2 here. So you see now I have 3 files, isn't it? This is my main code, which is now calling the display method. And here's my display class, actually menu class with the display method. And inside that, I have 2 methods. So in my test code, I'm not calling the main section to run. I'm calling only the sub method. We call the stub testing, right? These are stubs. So I know if the test deposit is running properly, I should get number 1. I know if I run test transfer, I should be getting number 2. Okay. So that's what I get here. So my code is correct, my stub is correct, and everything's working fine. So this is what I wanted to show you as an example of the top-down method. Okay. So what is then the opposite of that, the bottom-up method? This is called the mirror image of the top-down. Oops. right? So bottom up is the mirror image, with the difference that stubs are replaced by driver modules that emulate units at the next level up in the tree. Start with the leaves, that is, start with the bottom, like we did now, of the decomposition tree, and then test them with specially coded drivers. I think that's what I did now. I was testing the bottom sections and then see whether they are working. Okay. So there is one stub for each child node in the decomposition tree. So here's the way we look at it. So, so here we have the module, right? The bottom one we test, right? And they are all working together. Actually, they're being called by the top, we call it the driver module. So in our code, my driver module was the display function, and my submethods, the transfer, deposit, and all that, was the other modules under, right? So again, now how many drivers are required? So you have total number of node, we have 5, and number of leaf modules are called, like in a tree, this is called leaf. There are 4 leaves, so 5 minus 4 is 1. So driver means one program to call these guys, right? So this is the bottom-up method. Okay, so in a diagram, if you notice, you can see, okay, here are the modules. Module A is on the top, B, C, D, E, second level, F and G in the third level, and the H and I in the fourth level. So bottom-up integration goes from bottom to top. Top-down integration comes from top to bottom. I had to change my code a little bit for testing. I had to comment my display method, if you notice, in order to get the other two start testing. So that is actually bottom up, right? So I was testing the individual modules. Now, you can also combine these two, called the hybrid mode, right? In the hybrid mode, we combine the top and bottom and look at them together. Actually, this is a very special case. Now, what happens here is sometimes when you transfer code from 2-tier to 3-tier, let's say you have code where you have a UI with the logic code and then the database. As an example, let's say you have a database to store the data and you have a mobile application, let's say Flutter or a React Native or a Java Kotlin application running on the mobile. So the mobile application has both logic and the UI part together. So when you're installing the app, you're actually installing the logic and the UI together. And then it is directly storing the data in the database. There is no problem there. It's okay to do that. It is not okay for a very complex program. It's okay for a simple program. Yeah. And then let's say you want to break that in. You want to have an API engine where you can also have a web-based application. Maybe you want to expose the API to some others, maybe, right? So in that case, you are going to now break down your 2-level application into 3-level application. So the UI is just the mobile application, database as it is there, and in the middle, you will have an application layer. We call it the API layer or an application layer. So in that case, your testing that you did earlier from top down to bottom up now has a middle piece as well, isn't it? So that is called the hybrid layer. Okay. So here we have 3 layers. So top down is coming from top to bottom. Bottom up is going from bottom to top. And then hybrid is what is in the middle. Okay. Right. And then comes the next one, the Big Bang. Right. So what do you mean by the Big Bang? Well, as it says, you test the whole thing at once. Right. Instead of integrating component by component and testing, this approach wait until all the components arrive and one round of integration testing is done. So remember, wait until all the components arrive. So you can't test the whole thing when some pieces are being developed, right? So reduces testing effort and removes duplication in testing for the multi-step component integration. So this is good and bad actually. Now, when you do multi-step component testing, in a way it's good because you're testing one piece at a time and then you arrive at the big one. But here, you're testing the whole thing at once. So although you are removing the middle testing part, sometimes that might also be needed. Okay. Third point says why this is ideal or where this is ideal. Ideal for a product where the interfaces are stable with fewer number of defects, right? Meaning you have a product that is being tested multiple times using unit testing, integration testing, and then now sort of UI is also okay. Some of the layers are okay, and then now it is ready for the full testing or big bang testing, right? So this is also something where we can push it to alpha testing, beta testing, and also user testing if everything is going okay. Now here's an example. Integration testing of Stonewall company, right? So number A, user registration and authentication login module. We can test that. And then once you log in, okay, then you can go to product catalog testing. And in that, there may be product searching function also needed. So we can test that. And then we can add products to the shopping cart and see whether the shopping cart is working. And once you have some product in the shopping cart, you can see whether the billing and payment gateway is working, right? And then finally, we can look at shipping and package tracking. So billing is done, and then whether the shipping and packaging is also working. Okay. So now once all these modules A to F is ready, then you can go in and test this whole thing because the whole system is ready now. Right. Here is an interesting chart showing you how to choose the integration method because we looked at so many different methods, right? So what is the best one to choose? Top down, bottom up, hybrid, or big bang? If the requirements are very clear and the design is very clear, you can go with top down method, right? If the requirements are continuously changing and design is changing, the architecture is changing, then you need to go down to the detail and then do a bottom-up approach. So you check each bottom piece, test them, and then come up one by one. And then if the architecture is changing and the design is stable, design is okay, but the architecture is changing, right? In that case, you may have to do bi-directional. Sandwich or bidirectional. Sandwich is actually hybrid, right? So you may have to go up and down in your testing system or mechanism. And once you sort of achieve a certain reliability or stability, limited changes to existing architecture with less impact, right? So that means architecture is stable, you're not changing much. Whatever you're doing also has less impact. And then you can do a big bang testing. Right? If any of the above is a combination, then testing also can be any combination as well. So here's another diagram showing the things we discussed today. Bottom-up integration testing is where you have ABC, start from the bottom, C to B, B to A. Right? Top-down is A to B, B to C. Big bang, test everything. Right? Mixed, it can be top to bottom, bottom to top, either way. Right. So let's, since we talked about decomposition-based techniques, what are some of the advantages of this? Number one, improved manageability. What does that mean? Now, since you're looking at pieces of the entire big project, you can manage it also, isn't it? Piece at a time. And enhance understanding because you can see all the pieces. Now you can also understand the big picture. Parallel development, what does that mean? Since there are so many small pieces, you can give these pieces to either a team or individual people and things like that. And once these tested components are ready, maybe you can reuse also in other places. So there is a reusability advantage as well. And now since these pieces are running separately, we can also isolate the issues, isn't it? So if one is having trouble, we know exactly where the problem is. And scalability is another one. So scalability, we can go large to small to large, right? So decomposed systems are typically easy to scale because you can go to each piece and then optimize that, right? So that way you can scale it also. Because of all these things, your quality assurance is also much better because remember, quality assurance is about having a system. And you have a system where you are testing small pieces at a time. So that way you're also assuring the quality of the entire program. And also modularity and flexibility. Since we are dealing with many different small pieces in a module base, you can take some pieces away, add some more pieces into it, and then it has a very good flexibility also. Right. So what are some of the disadvantages of this? Now we looked at the advantages. What are the disadvantages? So number one is complexity. Right? Combining multiple components into a cohesive whole can be complex and time consuming. So although we say write separately small components, but then if you design it properly, it's okay. In the architecture design, if you sort of identify the small pieces, that's okay. But then if you keep adding things later also, then if the architecture is also changing, remember then you have to go top down and then do lots of testing again and again. So there is a lot of overhead cost, meaning multiple components, multiple testing, multiple integration testing, things like that. So now you notice I had to sort of, luckily I generated the testing code, but that code looks similar to the code I will be writing later in my start, right? So there's duplication also maybe happening there. And then dependency is another question. Now remember, I had to comment the display method in order to run the rest of the code because that was on the top when it was running and blocking my code and the test was not run. Yeah. So there may be consistency issues, like sometimes you may need to turn it on again, turn it off again. So why did you do that? So there may be some logical cohesion, the consistency issue also. Testing requirement is increasing because there are so many things to be tested. Yeah. And then what do you mean by communication overhead? Now, remember, there are lots of components, maybe developed by lots of different teams. And are they talking? Are they communicating properly? And I mean, end of the day, they will be integrating at one point, right? So if the information is not communicated properly, there will be issues later. Your testing will fail, and then it will take a long time to fix things, right? And also, when it comes to change management, that will be an issue as well, right? Because change management, remember, customers will always come back with changes and we can't say no to them. So how do you handle changes coming frequently to you? Right. So I have a few pictures to show you to understand a few different things when it comes to testing. Now, the pyramid shows unit testing has the most number of test cases, right? Why? Because there are so many isolated small pieces to test. So speed-wise, it's slow because so many things to test. Cost-wise, very cheap, right? Because you're testing the actually cost is not only the salary we are paying to the developer, right? Cost as in for the entire project, the cost to the company, cost to the brand name, things like that. So unit testing is relatively cheaper because you're doing it at the source code level. And then once the pieces are ready, you can do integration testing. Program units are combined and tested as groups. And once everything, all the big pieces are ready, we can do systems testing or the acceptance testing, which is done by most of the time the users. So that's called the real world scenario testing. And is another way to look at it, right? Different testing level. I also have other added layers here. Yeah. Unit testing at the bottom, component testing right on top of that, and then integration testing on top of that. So we generally stop there, isn't it? Now, there may be other also. Now, if you are writing, let's say, a backend that will be used by many different applications out there, you will have an API layer. Okay, so that API layer must be tested separately. And then that API layer will be consumed by maybe mobile or UI, I mean, a website. Yeah. So there again, we have to test the front end side to see whether it is working as per the specification, or rather it is talking to the API properly. Is it talking to the API properly, and the API is sending us the data properly? Okay, so you see, we can go into multiple levels as well. Now, most of the time, if you look at nowadays programs, we have disconnected program, isn't it? So we use something called the MVC architecture, model view control architecture. So view can be either a website or a mobile app. Controller is our application layer. Model is our database layer. So generally, the application layer also probably maybe API-based engine, probably API engine. So there we need to break it down into component. We have to do integration testing there. And then down to the function level, we need to do unit testing also. So if you're working for a company that is building a large scale application that uses APIs and also other front ends, then you need to come down to multiple layers to make sure that testing is there, right? More complex the project, more testing is needed. Here's another way to look at it from a software testing point of view. So we have manual testing and automated testing. We didn't go to the automated testing yet. So under manual testing, we are looking at white box, black box. There's also gray box, by the way, a combination of these two. Under black box, there is functional and non-functional. So functional is what we did today: unit testing, integration testing, and system testing. Right? Non-functional is where you have things like performance, usability, compatibility. Under performance, you do load testing, stress testing, stuff like that. So for a serious application, all these boxes are required. Okay. So this has to be part of the development discipline in an organization. So you're not just sitting down and writing code, and then giving it to the customer. No, you have to do lots of different things when it comes to testing as well. So that's why testing is a very important aspect when it comes to software development. Here's another one showing 13 types of testing. Right? We spend only time on main ones. I'm only talking about the main areas, but then there are so many, right? Sanity testing, smoke testing. Then there is load testing, end-to-end testing, compatibility testing. So, of course, you can expand your basic testing level to any other level as you wish. Right? So, my lecture today is coming from section 7 of our textbook, Software Quality Assurance Self-Teaching Introduction. So, please go through that. I basically distill down what is in the book into these slides. Reading it will give you much more details. Okay, let's get the attendance now.